Okay, so now we're going to talk about that bell curve that we mentioned before. So normal distribution of z-scores are something that we're going to kind of focus in on here for just a few minutes. Normal distribution is a bell curve, and it's called that because it looks like a bell shape. And what it does is it shows how the data is distributed from the mean. So again, similar to what we were talking about before with the dispersion, but what happens is we end up with this data and we have an average, and we know what the average is. And we want to see kind of how the data gets distributed from that point. And so you end up with this piece of information where 34% of the information is going to be to the right of that and 34% to the left. And what these are is these are each standard deviations. And so for each standard deviation, so here's the middle, one standard deviation goes here, one standard deviation goes here. You end up with basically 68% of all the data falls within this window. And this is for a normal distribution. So sometimes things are not distributed exactly normally, and so our bell curve looks a little bit off, and it's going to be a little bit, things are shifted to the right further or to the left further. But one deviation, standard deviation, will give you about 68% of the information. Then if you go 2 deviations, so all the way out to here and here, you end up with about 95% of the data. And then 3 deviations and you're at 99% of the information. And so you're kind of dealing with outliers out here at this point. But this is just kind of a normal distribution, something that is distributed evenly. This is what your data is going to look like when you put it into that bell curve. Okay, and so here is what we have. All right, here's an example. We have the grades on a statistics midterm are normally distributed. Okay, normal distribution is what we're talking about. So that means that our data is going to be distributed just like this example up here, all right, with an average of 81 and a standard deviation of 5, meaning between each of these little blocks, you're going to be dealing with 5 points variation, okay, because we're dealing with points here, okay. So here's what we're going to do. We're going to draw a curve, all right. So we have our line, we have our shape, okay, and the middle here is going to be our average, which is 81, okay, and then we're going to go 1 standard deviation, all right, and so what that means is we're going to be going an additional 5 points to the right and 5 points to the left, all right, so that means an 86 or a 76, okay, that's 10 points basically between right there around your average score. Okay, and that means we've got 34% of the data here and 34% of the data here. Then we're going to go out 1 more standard deviation. That's 5 more points out here, which would put us at a 91, and 5 more points this direction, which puts you at a 71. That's an additional 13.5% of the information on each of these sections. And then there's another standard deviation where we end up with 96 as a score, or down this way a 66, and that includes another 2% of the data. And then the final little section here is a 0.5%, where you end up with somebody who has above a 96 or below a 66, okay? And so this is kind of how the information gets split if it's normally distributed. Okay, so if we look at the data, how much of the data falls, the numbers, between 76 and 86? Okay, so from here to here, that's 34% and 34%. So 68% of the scores for this test fall between 76 and 86. Okay, then we look at, well, what happens if we go out 1 step further? What if it's from a 71 to a 91? Well, how much information, how much of the data is collected now? Well, we add another 27%. So we end up with 95%. Okay. And then, well, what happens if we go out further than that and we add another 4%? Well, we end up with a 98%, but that's not the question, so make sure you pay attention. It's asking now, what percent of the data falls between 81 and 91? So what if we're just going between 81 and 91% here? Well, that's 34% here and 13.5% here. So added together, that's going to be 47.5%. So almost 50% of the data falls right here between an 81 and a 91 score on that test. Okay? And then the question is, what percent of the data is less than 86? So we take out these first three sets and we have from an 86 down, and we add all of this together. And what we end up with is 84% of the test scores were below an 86. Okay? And so that's the kind of information that we're looking for when we start looking through examples of normal distribution. Okay? So then what we start talking about is something called a z-score. Okay, so I'm going to go ahead and we're going to stop a video here. I'm going to do one more video and we're going to talk specifically about z-scores on that one.